This is how to do stoichiometry calculations using proportions. First, let's look at the rules on how to set up these problems. We're going to put our given and our unknown information in above the equation. So you're going to draw out line equals line. And on the left-hand side of that is going to be where you put your given information. So it's going to be a number and a unit. And on the right side of the equation is where we put the unknown information. And that's going to also be a number and a unit. On the bottom of the equation, we're going to use the coefficients from the equation to write the amounts below the equation. So you're going to write your coefficient here times some information, and then same thing on this side, the coefficient times some information. Now, what is this information in the parentheses? It's going to depend. Whatever unit this is up here is going to tell you whether or not you're going to choose to put 1 mole, 6.02 times 10 to the 23rd, 22.4 liters, or molar mass, which is grams from the periodic table. And that's going to be the same thing over here. Whatever the unit is here, the unknown, what we desire, is going to be 1 mole or 6.02 times 10 to the 23rd. And this is going to be atoms, molecules, formula units, etc. And then 22.4 liters or molar mass, which if you don't recall is grams, and we get it from the periodic table. So whatever you have unit up here, that's going to tell you which of these to put in the parentheses at the bottom. Same thing on the right-hand side. We're going to multiply it by the coefficient from our balanced equation. So you want to choose the one that matches the respective numerator unit up here. So whatever unit's here is going to be which one of these you're going to put in the parentheses at the bottom. So let's see an example problem. This is our balanced equation. So that means that my coefficients are going to be 4, 1, and 2 for each of these compounds, sodium, oxygen, and sodium oxide. So now let's look in the problem and locate our given. And here it is, 5.00 moles of sodium. You have to identify not only the number of your given, but the unit and of what is it, because that's going to tell you which coefficient we're going to use in the equation as well. Now let's identify what is our unknown. And here it says calculate the number of moles of sodium oxide, or Na2O. So this is my unknown. That's the question right there. So we're going to set up our proportion now. Here is our proportion. We're going to put our given here, which is 5.00 moles of sodium. That's our given right there. And then our unknown is over here, and we're going to say X moles of sodium oxide. That is our unknown right here, X, because we don't know what it is. Now we're going to set up the bottom, and remember that whatever unit you have on top is going to have to match the unit at the bottom. So first, let's put our coefficient. Sodium has a coefficient of 4, and sodium oxide has a coefficient of 2. Times. Since we have moles in the numerators, we want to choose 1 mole to be in the bottom in the parentheses. And that's going to be for both of them, because that's mole, so we'll put 1 mole here, and because that says mole, we're going to put 1 mole here. Now we're going to do some math to solve for our X, which is right here. So we're going to do some cross multiplying, which means we're going to take this times this, 5.00 times 2 equals this times this. So it's going to be the 4 times the X, which gives us 4X. And now we're going to solve for X. Of course, 5 times 2 is 10 equals 4X. And then we're going to divide both sides by 4 in order to get X is equal to 2.5. And this is going to have this unit here of our final answers. That's 2.5 moles of sodium oxide is our final answer. So this should be 2.5 moles of sodium oxide. Let's try the next example. First, let's identify what is our given. And our given is going to be this, 3.2 moles of potassium chlorate. And which one of these is potassium chlorate? That's going to be this one right here. And notice it has a coefficient of 2. Now, what is our unknown? How many moles of oxygen is our unknown, and that's going to be this in our equation, which has a coefficient of 3. So now we're going to set up our proportion. Our given is 3.2 moles of KClO3, and our unknown is X moles of oxygen, which remember it's a diatomic, so it's O2. At the bottom, I'm going to put my coefficients. So for KClO3, the coefficient is 2, and for oxygen, the coefficient is 3 times. And now, what are we going to put in these parentheses? Well, whatever your unit is in your numerator tells you what to choose in your denominator. And so we're going to choose moles because both of these have moles in their numerator. So we're going to put 1 mole and 1 mole in the parentheses in the denominator. Now, we're going to cross multiply this in order to solve for it. So to cross multiply, first we're going to have this times this. That's 3.2 times 3 times 1, which is 3. And then equals, and now we'll do this times this. 2 times 1 is 2. And then 2 times x is 2x. And so now we can solve this proportion. 3 times 3.2 is 9.6 equals 2x. So we just simplified these by multiplying them. Now I'm going to solve for x by dividing both sides by 2. And then that's going to give us x is equal to 9.6 divided by 2, which is 4.8. Remember, that is of this right here. That's our unknown. So it's 4.8 moles of oxygen. Let's try our next one. Our given in the problem is 15.0 moles of oxygen. And that's going to be this in our equation. And notice it has a coefficient of 1. When you don't see a coefficient, it's automatically a 1. The unknown in our problem says how many moles of water. So moles of water is our unknown, and that's going to be this one right here. Notice it has a coefficient of 4. So now we can set up our proportion. Put our given on this side, 15.0 moles of oxygen and X moles of H2O. Now, the coefficients for oxygen, it's a 1. So we're going to put 1 times. And then over here for water, the coefficient is 4. So 4 times. Remember, whatever unit is up here is going to tell us which of these I have to choose down here. So since we have moles at the top, we're going to choose 1 mole for both of these because they're both 1 mole. So we're going to put 1 mole here and 1 mole here. Now, in order to solve this, we're going to cross multiply. So it's going to be this times this, 15.0 times 4 times 1, which is just 4. So this is going to be 15.0 times 4 equals this times this, which 1 times 1 is just 1, and then 1 times x is just x. So in this case, 15 times 4 is going to be equal to our x. So x is going to equal 60. Remember, this is the unit of our answer, so it's going to be 60 moles of H2O. In this one, identify your given. 2.9 moles of N2H4 is our given. N2H4 is this right here, which has a coefficient of 1. Then our unknown is how many moles of N2. So that makes this our unknown, and it also has a coefficient of just 1. So now we can set up our proportion. So our given is 2.9 moles of N2H4, and our unknown is the X moles of N2. And then below, you're going to put the coefficient of 1 there and 1 there, because those are our coefficients in the equation. And then remember, the numbers at the bottom in the parentheses have to match. So since that says mole, I'm going to choose 1 mole to go at the bottom, and since the unknown is also moles, I'm going to choose 1 mole to go at the bottom. Now we can cross multiply these to solve for x. So it's going to be this times this. So 1 times 1 is just 1, and 1 times 2.9 is just 2.9. Equals this times this. 1 times 1 is 1, and 1 times x is just x. So here we already have our answer. X is equal to 2.9. Remember that this is what your answer is. So it's 2.9 moles of nitrogen, and that's our final answer. Now let's look at a more complex set of stoichiometric calculations. So we're going to, again, find the given, which in this case is 35.0 moles of ammonia. And ammonia in our equation is going to be this one right here, NH3. Notice it has a coefficient of 2. And then we're going to find our unknown, what mass of nitrogen. And it's important to note that the unit for mass is grams. And so we're looking for the grams of nitrogen. In our equation, here's nitrogen, and it has a coefficient of 1. So now we can set up our proportion. The given is going to be 35.0 moles of ammonia, and the unknown is going to be X grams of nitrogen. And notice I'm going to use the formula, nitrogen is N2. It's one of our diatomics. Let me go ahead and put the coefficients at the bottom. So for ammonia, the coefficient is 2 times something, and for nitrogen, the coefficient is 1 times something. Now, by now, hopefully you realize that if we have moles in the numerator, that means you need to put 1 mole in the parentheses in the denominator. However, over here we have grams. So where do we get grams of nitrogen? This is going to be the molar mass of nitrogen, and you get it from the periodic table. Nitrogen on the periodic table has a mass of 14.01, and because there are 2 nitrogens in the formula, 14.01 times 2 is going to be 28.02, and that's my molar mass of nitrogen. I got it from the periodic table, and it's in a unit of grams. Now we can solve this proportion. We're going to take this number times this number. So 28.02 times 1 is just 28.02. So we're going to have 28.02 times 35.0 equals, and then it's going to be this times this. 2 times 1 is just 2, and then 2 times x is 2x. So now we're going to solve for x. Let's simplify these two by multiplying them, and we get 980.7 equals 2x. And now I'm going to divide both sides by 2, and when I do that, I'm going to get 490.35, and that's going to be equal to our x, which is our final answer. That's our grams of nitrogen. Here's the next example. What is our given? It is 100 moles of hydrazine, and this is going to be our hydrazine. Notice it has a coefficient of 1. What is our unknown? Well, how many molecules of oxygen is our unknown? And oxygen is here, which also has a coefficient of 1. So now I'm going to set up my proportion. I've got my given 10.0 moles of hydrazine and my unknown X molecules of oxygen. I'm going to put the coefficient of hydrazine here times, because that says mole, I'm going to put 1 mole in these parentheses. Over here, my coefficient is 1 times, and what am I going to put in the parentheses here? This says molecules. So which of these is molecules? It's not mole, it's not liters, molar mass is grams, so this one is going to have to be molecules. This is Avogadro's number, and it could be formula units, atoms, or molecules. So we're going to put 6.02 times 10 to the 23rd, and that's molecules in the parentheses. Now we can solve our proportion, so we're going to start with this times this, so we'll write 10.0 times, and then 1 times Avogadro's number is just 6.02 times 10 to the 23rd equals, and now it's going to be this times this. 1 times 1 is just 1, and 1 times x equals x. So when I multiply these two numbers, I'll get my final answer, which is x is 6.02 times 10 to the 25 molecules of oxygen, because remember, when we solve for x, this is the unit of that answer. Okay, number 2, let's identify our given. 56.7 liters of hydrogen gas, and that's going to be here, and it has a coefficient of 1. Our unknown is how many moles of sodium are needed, and here's sodium, and it has a coefficient of 2. So let's set up our proportion. So our given is 56.7 liters of hydrogen, so we're going to put that here over the coefficient of hydrogen is 1, and then we'll figure out what to put here in a moment. Over here is our unknown X moles of sodium, and it has a coefficient of 2, and then we'll look and see what goes in here as well. So when we look back here, When you have liters in the numerator, then you're going to choose 22.4 liters to go at the bottom. And when you have moles in the numerator, you're going to choose 1 mole to go in the parenthesis at the bottom. Now, we're going to solve this by cross multiplying. So we'll start here, and we're going to take our 56.7 liters times 2 times 1, and when you do that, you get 113.4 equals, now it's going to be this times this. 1 times 22.4 times x is just 22.4x. We'll divide both sides by 22.4 in order to solve for x. And when we type this into our calculator, we get 5.06. And remember, this is going to be the moles of sodium. In number 3, our given is 137.9 grams of butane, and they tell you that this is butane. It has a coefficient of 2. Our unknown is what is the mass of oxygen. So our mass of oxygen is there, has a coefficient of 13. So now let's set up our proportion. Our given is 137.9 grams of butane. And notice I put it over its coefficient, which is 2 times, and then we have our parentheses. Our unknown is x grams of oxygen, and I put it over the coefficient of oxygen, and then what we're going to put in the parentheses here. So because I have grams in the numerator for both, you're going to choose to put in the denominator the molar mass, which is grams for each of these. Moles, molecules, atoms, formula units, that's liters, and molar mass is in grams. So to get the molar mass, you have to go to the periodic table and add these up. So we're going to go find carbon is 12.01, and we're going to put that in our calculator, times 4, plus hydrogen is 1.01 times 10, and that's going to give us a mass of 58.14 grams. And then for oxygen, it is 16 grams on the periodic table. I have 2 of them, subscript of 2, so 16 times 2 is equal to 32 grams for my oxygen. Now we can cross multiply. We're going to do this times this. And if you want to do some simplifying, you can. Like we can go ahead and multiply all of these numbers immediately. 137.9 times 13 times 32 equals, and that's going to get us quite a large number, 57366.4 equals, and now we're going to do this times this. I'm going to go ahead and multiply 2 times 58.14, and then that's going to be times x, which is going to give us 116.28x. Now to solve for x, I'm just going to divide by 116.28 on both sides, and then we'll get x is equal to 493 grams of oxygen. Okay, let's look at our next problem. Our given value is 5.25 grams of zinc, and that is this right here. It has a coefficient of 1. Our unknown is what volume of zinc chloride, and this is zinc chloride. It also has a coefficient of 1. So now we can set up our proportion. I'm going to put my given value on the top here, 5.25 grams of zinc. Notice underneath it I put its coefficient, which is a 1, times something in the parentheses, equals, and then what is the volume of zinc chloride, and then put it over 1 because that is its coefficient times something in the parentheses. Now look at the numerator. This is grams, so I'm going to use the molar mass at the bottom for the left side. So the molar mass of zinc on the periodic table is 65.39, and so that's what goes in these parentheses right here. On the right side, we have liters in the numerator, which means I want to use this, 22.4 liters in the denominator. Now we can cross multiply, and if you want to go ahead and use your calculator, it's going to be this times this. So I'm going to type in 5.25 times 1 times 22.4, and that's going to give us 117.6. Then we're going to write equals this times this, and 1 times 65.39 times x is just 65.39x. Now I'm going to divide by 65.39 on both sides in order to get my x, which is going to be equal to 1.80, and remember that is liters of zinc chloride. Okay, number 5, we're going to see our given is 4.75 liters of hydrogen gas. Here's hydrogen gas, which has a coefficient of 1. And then our unknown is how many atoms of zinc. And here's our zinc, and it has a coefficient of 1. So let's set up our proportion. So we have our given 4.75 liters of hydrogen at the top there, and we have X atoms of zinc at the top here, our unknown. Our coefficient for hydrogen is 1. Our coefficient for zinc is 1. And now what's going to go in these parentheses? Because this has liters at the top, that means at the bottom I want to use 22.4 liters. And because this has atoms at the top, I want to use this, 6.02 times 10 to the 23rd atoms at the bottom. Now we can solve our proportion. We'll start by multiplying these values, 4.75 times 6.02 times 10 to the 23rd, and that's going to give us 2.8595 times 10 to the 24th, right, equals, and now we'll multiply here to here. So it's 1 times 22.4 times x, which is just 22.4x. And now we can divide both sides by 22.4 to solve for x. And x is going to be equal to 1.277 times 10 to the 23rd, and that's going to be atoms of zinc. Here's our final calculation. The given is 877 grams of phosphorus trichloride, which is this right here. That's got a coefficient of 2. And our unknown is what volume of chlorine gas, and that's going to be this right here. So we're going to set up our proportion where my given is 877 grams of PCl3. I'm going to put the coefficient underneath times, and we'll see in a minute what goes down there, equals, and my unknown is x, volume is liters of chlorine gas, and chlorine is this, so my coefficient is 3 times something in the parentheses. Okay, so let's go ahead and look this up first because that's going to be the easiest one. Because we have liters at the top, we need to pick 22.4 liters to go at the bottom. And then on the left-hand side, because this is grams, that means that down here I'm going to need the molar mass in grams. So we're going to go to our calculator and our periodic table, and we're going to add up phosphorus is 30.97 plus chlorine is 35.45 times a subscript of 3, and that's going to give me a mass of 137.32 grams. Now that we have our proportions set up, we can solve with cross multiplication. So it's going to be here times here. So let's do 877 times 3 times 22.4, and that's going to give us 58934.4 equals, and then it's going to be this times this. So we're going to do 2 times 137.32 times 1x is going to give me 274.64x. And now to solve for x, I'm going to divide both sides by 274.64. And this is going to cancel. X is going to be equal to 214.59. And remember that is liters of chlorine.